Hello everyone. I'm happy to welcome you through this course, Introduction to Data Science. And more importantly, I'm delighted to introduce this course to you, which is the introductory part of the course, first session. Before we move further, by the end of this session, you should be able to define data science and describe its scope, describe the classification of data, explain why data matters so much in today's world, explain the key challenges that data scientists face. Now, without wasting most of our time, let's jump right straight in. What is data science? There has been a lot of misconception about the definition of data science. Most people often think that data science is just coding or statistics. I'm happy to tell you that it is neither and it is both. Yes. So what is data science? Data science is an interdisciplinary field that uses scientific methods, algorithms, and systems to extract knowledge and insight from data. Now, that is technical. In the simplest form, data science takes raw, messy information and turns it into decision. Now, the question now is, how does this transformation take place? This transformation happens through 8 core components, and I will walk through all of them like a pipeline, one by one. Now, these are the steps. These are the data science pipeline. The first one is data collection and management. Now, what do we mean by data collection and management? It has to do with gathering of raw data from different sources such as database, web API, and API is application programming interface. The second step is data cleaning and pre-processing. After you have collected the data, real data is messy, so it needs to be cleaned and processed. And most importantly, why do you need to clean data? One, most of the real world data, they are full of errors such as missing values, duplicate entry, and so on and so forth. Now, the third step is exploratory data analysis. With exploratory data analysis, you summarize and visualize data in order to understand shape, spot patterns, and anomalies. The fourth step is statistical analysis. With statistical analysis, you are applying rigorous techniques to test hypotheses and validate relationship. Now, the fifth step, machine learning and predictive modeling. Now, you are using algorithm to learn from the data. So the algorithm could be supervised learning, unsupervised learning, and reinforcement learning. The sixth step is data visualization. Now, most of your stakeholders, they are non-technical. So you have to break your technical explanation in such a way that it will be understandable by non-technical audience. So you are translating complex insights into a graphics, such as you can use bar charts, you can use pie charts to explain to your relevant audience. The seventh step is big data technology. Now, every day we are generating data. You have massive data. So handling all this data involves expensive infrastructure, such as Adobe, Spark, and so on and so forth. While the last step, which is deployment and monitoring. You have to put the model that you have developed into production, then you track the performance as condition shifts. Now, let's move to the classification of data. Now, with data, not all data are the same. That determines how we work with it. The first classification is structured data. If you are talking about structured data, you're talking about rows and columns. Example is spreadsheet and SQL. Okay, picture structured data like a label folder with a street template. The second type is semi-structure. With semi-structure, it has tags but flexible. An example of semi-structured data, they are JSON. JSON is JavaScript object notation. You have XML, and it is organized and no fixed schema. So you can picture semi-structure like a folder with sticky notes, some kind of order but flexible. While the last one, which is unstructured. So from the word unstructured, it means that it has no predefined model. An example is your text, images, video, and so on and so forth. So you can picture unstructured like a pile of newspaper and photos full of content, but it takes effort to sort through. Now, what are the scope of data science? If you are talking about scope of data science, we are talking about areas where data science are applicable. Number one, you can use it in business, healthcare, finance, government, education, and so on and so forth. Now, why does data matter? You know, at the beginning of the session, I said there is a phrase called data is the new oil. Now, why is it that data is so important? Why is it that data has become the critical organization asset now? Now, I would like to give you 5 reasons why data matters. The first one is for decision making. Now, if we are talking about decision making, with data, you have replaced guesswork with evidence. The second one is efficiency. Now, with data, you will be able to spot bottleneck hiding in plain sight. Now, the other one is customer insight. With data, company can now understand what customer truly wants, not what company wants to produce. Then we have innovation and competitive edge. Company with data, they have advantage over company without data. Challenges in data science. Now, data science is an interesting field, no doubt, but it comes with its own challenges as well. One of the challenges is privacy and security. Most people, they mishandle data, and mishandling of data can cause threat. The second one is data quality, scalability, collaboration, and interpretability. Now, in conclusion, I'll be able to walk you through the definition of data science, which is an interdisciplinary field, turning raw data into decision and built on 8 core components. Now, we'll be able to talk about classification, which is structure, semi-structure, and unstructured. Then we'll talk about why data matters. We give some of the 5 key reasons, like decision making, efficiency, insight, and so on. Then we'll talk about challenges that is associated that data scientists face nowadays. Now, before the final caps, I would like to do a kind of self-assessment of what I've been taught so far. Now, I would like you to define structured data for me and give me an example. Mention 5 areas where data science can be applied in real world. Then measure the 8 core components of data science. Thank you. I will see you in the next session.